Now I'm recording. Thank you, Mariah. All right, so let's start by looking at number 12. Now, it says that each side of rectangle A is 5 times as long as each corresponding side of rectangle B. The area of rectangle A is how many times the area of rectangle B? Now, they don't categorize, like they don't tell you what category of question it is on the test. It's just like another question, and they'll be very random. So, but anyone have any thoughts on whether this is an algebra question, geometry, or statistics, or measurement?
Measurement.
Honestly, it's kind of a hodgepodge. It has a little bit of measurement.
Yeah.
It would probably look in geometry. But I kind of feel like there's a little bit of algebra as well. So, but it's, or at least it's sort of algebraic types of thinking. So here's one thing you want to be aware of. If you can kind of see, oh, they're talking about rectangles and they're talking about area, there is a formula sheet you want to know about. So, and it's very, very geometry heavy. So anytime there's a geometry question, you want to consult the formula sheet to see if there's anything on there that could help you. They were talking about rectangles, right? Well, here's a section that says area, and sorry. Now, do you see area of a rectangle in there anywhere? These are the only area formulas they gave us. And the question we were looking at says rectangle.
No.
Well, it doesn't look like it, but here's how this formula sheet gets you. A rectangle is just a very specific kind of one of these, called a parallelogram. We can have other like rectangle looking like things, like sometimes I call it like a rectangle that's sort of like leaning over. But that's called a parallelogram. But a rectangle is a special kind of parallelogram where we have perfect right angles. So there, we got like 490-degree angles in there. So that would be helpful, right? Because if you're looking for the rectangle formula, it's like, oh, I don't see it. But this is a formula for any parallelogram, including a rectangle. So it's the base times the height. Okay. Sorry, I just now saw a question here. So is there a way for Earhart to share? Yes. I think you might have control. Maria, I'll get to that in a second. Nancy, you may have control over that on the bottom of your screen. Sorry.
Okay.
I think there's a way to, let me see here. See where it says share screen?
Yes.
There's like a little arrow in the top right hand button. I think it should give you some options to like advanced sharing, like.
Oh, okay.
I think there's a way you can mess with that. And
okay, I'll work with that. Okay, thanks.
Yeah. Maria, to answer your question, when you're taking the test and it's on the computer, it'll just be like there'll be like a toolbox of things at the top of your screen, and you can pull down the formula sheet at any time. On the sheet that I have now, you can access this on the highset.org site if you so desire, but it's just, they throw it in there right before the test. So it happens to be page 3 of this little test that they are through. And the first 2 pages, just the cover sheet, but they show you the formula sheet there. And then they give you the instructions. Like if you were going to take this in person and time yourself, this is about the time frame they would recommend to try to do these 25 questions in 45 minutes. The actual test is about double that length. So that Maria was just wondering where the formula sheet would be. All right, so anyway, back to where I was. That is, you have to know that a parallelogram is a type of rectangle. So we're going to be doing the base times the height to find the area. Let's go back to number 12. So now, because they did talk about the areas. So let's pretend, as we're sort of making our picture, I highly recommend that you kind of draw a little picture here. So the way I'm reading this is that rectangle A is a bigger rectangle, rectangle B is a smaller rectangle. So this is your rectangle A, rectangle B. And it says that each side of rectangle A is 5 times as long as each corresponding side of rectangle B. So we got to sort of dig through the verbiage, right? Like the vocabulary of this. So when they say corresponding side, what exactly do you suppose that might be referring to? So like a rectangle has four sides. Okay. Side 1, side 2, side 3, side 4. So you've got like this top side. Here's the top there. Right? I would say that that top piece corresponds with the other top piece. That's what we would call corresponding side. Same with bottom corresponds with the bottom. Right side corresponds with the right side, and left side corresponds with the left side. All right, so that's what we mean by corresponding side. Now let's look at the other information they told us, that rectangle A, each side of rectangle A is 5 times as long as the corresponding side. So when we compare the areas, how many times is area angle B? So, what do you do with that? Like, what do you, we don't really, we're not given any information about any specific lengths at all. So it almost can come across as a very impossible question, but this is sort of what I like to call the magic of math here, is that it doesn't matter what the numbers are if this is true, right? So this might surprise you, but we can actually make up a number, all right? So can somebody give me a number, let's say, let's see, 3. Let's start with the smaller rectangle, and just give me a number between 1 and 10. Anybody shout? Say again.
2.
2. Okay, let's make 2 the smaller side here. All right. Now, based on what they described for us, if the length of the smaller side is 2 and the corresponding side of the bigger triangle is always 5 times as long as that, what will the length of that side have to be? Five times as long as this.
10.
10, exactly. Okay. Now, someone else give me a number that's bigger than 2 that we'll put for our top piece here.
Four.
All right, we'll make that 4. All right. And so if the top piece of the smaller triangle is 4 and the corresponding side of the bigger triangle will be 5 times as long as that, what will the length of this top piece be?
20.
20. All right, great. All right, now let's compare the areas. So the area of any rectangle is always the base times the height. Sometimes they say length times width. You can call it whatever you want. It's this one dimension times the other dimension. All right, we'll call the height 10. That's really, the order doesn't matter here. The base is really, see, if this top piece is 20, well, the bottom piece is going to be the same length. Okay, that's how rectangles work. So the base, sometimes we think of the base as the bottom. So at any rate, it's 20 times 10 is how we find that area. So what is 20 times 10?
200.
200. Yep. And if you don't feel confident on doing that in your head or by hand, don't feel bad about using the calculator. Just pull that thing down and use it. Do 20 times 10. Enter. All right. Now let's do the same for the other one. We're going to do find the area of this rectangle. Base times height, 4 times 2, which is
8.
8. All right. Now we're going to compare the area of this bigger one to the area of this. How many more times is 200 than 8? So in other words, 8 times what number will equal 200?
25 times.
25, right? And if you're not sure, you've got choices here. Let's see which one I can multiply by 8 to get 200. Answer is 25. You might think, well, that's what it was on that one. We just made up the numbers. What if I pick something else? Well, it'll always be 25. Now, I don't expect you to do this on the test, but I'm just teaching you right now that it actually does not matter. So I'm just going to prove it as fast as I can right now. Let's make this 3 instead. Let's make that 7. And we'll make this 35 and 15, because those are 5 times the other ones. 35 times 15. Maybe I shouldn't have picked such a big number.
25.
35 times 15. 525. So area is 525. And for the smaller one, the area is 21. Right? So 21 times what number will equal 525? I think it's 25. If I do 21 times 25, will that be 525?
Yes, it's
Yes.
a answer.
It is, yep. So it's like a magic trick, really. It's going to always work. As long as it's like they call it a proportion or a ratio or a proportion. Or if we have that sort of feature happening with the corresponding size, we call these similar figures. So with similar figures, yeah, we just know it doesn't matter what the numbers are. So they don't have to give us any actual numbers. You can, in this sort of scenario, you can just make them up and then make this happen. So I thought it was easier just to start with the smaller one and then multiply those by 5. You had to know how to find the area. So that's why knowing that where to find that information on the formula sheet is helpful. Okay, go on to 13. Give me a second. I had a text message come through and make sure it wasn't something for this class. Okay. All right, let's look at 13. Polygon A will be translated in a coordinate plane using the following rule. Call this a rule. The image will be named polygon B. Which of the following describes the translation from polygon A to polygon B? So what is a polygon? Definition time here. It's a polygon. I know you can't do this on the test, but if somebody wants to Google it and give us a definition, that's nothing wrong with that while we're learning.
It's a 5 points shape.
It could be 5, but it doesn't have to be 5. There's a pentagon. That's a specific one for 5 sides. So somebody looking that up? Look up the definition of polygon.
Is it a plain figure with at least 3 straight lines?
Okay, yeah, a plane figure, there's at least three. So even like a triangle could be a polygon.
And an angle, yeah.
Yeah, a rectangle even, or
Yeah.
Maria was talking about a pentagon, or if it has 6 sides. I can't draw these very well, but anything if it has at least 3 or more, theoretically you could have a 100-sided polygon.
Yeah.
Some of them have specific names, but anyway, they don't care what kind of polygon it is, but we're just referring to it as polygon A. There's some random shape and it is on a coordinate plane. Now, what do they mean by a coordinate plane? If I want to look that up. These are examples of polygons. A coordinate plane.
Coordinate point is that the kind of where the points goes together with
Mhm.
X is Y and X.
You got it, yeah. X-axis, Y-axis. So that's a coordinate plane. See, a plane in geometry is like a flat surface. So I would say, imagine you've got, like right now I'm sitting at my kitchen table. Well, if I could imagine that kitchen table was going to go forever in both directions, that would be a very flat, an infinitely flat surface, right? So that's what a coordinate plane is. Your horizontal is your x-axis, your vertical is your y-axis. So when we see this thing in parentheses with x comma y, it's referring to a very specific location on that plane. Almost imagine like a map, right? A map of a city or something. And we've got some north-south streets, east-west streets. So each one of these points could be a specific location. And the first number represents the horizontal distance from the center, and the second number represents your vertical distance from that place that we stopped, or that place where we left off. So what they're saying when we translate, so this is a coordinate plane. We're kind of getting our definitions down. Got polygons, just a random shape. It is translated in this thing called a coordinate plane. So now hopefully you know what that is. But what does the word translate mean? I know we're all thinking, okay, well, I translate. If I say adios, you translate that to goodbye. That's a language translation. But what does it mean in a geometry world, like to translate something?
To represent as a graphic.
Okay, yeah, we're going to represent it maybe a different way. I mean, in some respect, it's similar enough to how we translate languages. Like I'm changing it from Spanish to English or from English to Spanish. So I'm changing this shape from one location to another. Okay, it's going to be translated. So what that actually literally means is it's going to be shifted. Right. So imagine I've got like a triangle or something. If I could take this triangle and literally like slide it somewhere else, right? What this tells us is how it's being slid. And basically each ordered pair, this is going to say that the first number of your ordered pair is going to go up by 3. And the second number is going to go down by 4. Okay. And up, I mean up in like numbers. So like if X was a 5, it's going to go up by 3 to 8. If Y was a 7, it'll go down 4 and go down to 3. So, but now you got to think about your picture here. So based on what I've shown you now, what I've described here, which of these choices makes the most sense?
D as in dog.
D as in dog. Yeah. Because although the number is going up, remember the X is horizontal. So it would have to go to the right. And then your second number is a vertical shift. And so it's going up for the second number for your y. Very good. All right. So that one's really not so bad. Like once you know what exactly they're saying, it literally is like a translation. Like this is like its own geometry language that just says that every point is going to be shifted to the right 3 and down 4. So we're just moving that shape over and down. That makes sense? That's very exciting stuff. Okay, now, so we've done a couple of geometry questions. Now, how do you think you would describe 14? Like, what kind of math is this?
The fun algebra.
Definitely algebra. Yeah, once they throw in letters with numbers, if they're crammed together, that's definitely algebra. So algebra is literally its own language, and we have to learn how to read it and interpret it. And there's a lot of like invisible things that happen in algebra, just like, you know, when we, even in English or other languages, like there might be sounds that we make that aren't really there in the letters. I don't know, like for example, if we say fame, well, we don't say fame-y, right? We don't pronounce the E, it's just silent. So sometimes we have like silent letters. So that was just an analogy I kind of just thought of. But in the algebra language, there may be things that intend to be there, but aren't really there. You can't see it. So one example of that is with what we have here. We have this 10 and we have this A, and then we have this 6 in the corner. In between the 10 and the A is like implied multiplication, all right? We are multiplying 10 times something else, right? It's invisible multiplication. Sometimes I will tend to like write it out like this with like a little dot to indicate I'm multiplying by something. Now, this part with the letter and the number in the corner, this A, we don't know what A is, but it is a variable and it just represents some sort of unknown value. And then this number we refer to as an exponent. All right, so this is a variable. And this variable is, when it goes with an exponent, we also refer to this as the base, so that we have a base and an exponent. So an exponent always has a base, right? The base is on the bottom. So we would read this as a to the 6th power. All right, so that has its own meaning as well. So let me rewrite that again. So a to the 6th power. A translation, shall we call it? Like, what is this actually saying? What this really means is that we're taking whatever a is and we're going to multiply it. I'll use that little dot again. It's not a decimal, it's like a floating dot. So we'll say that's the same as taking a times a again, times another a, times another a, times another a. We're going to do that 6 times. So that's what the purpose of the exponent is to tell us how many times we would be multiplying that a together. So this, I'll erase what was originally there. So I would read this in my mind as 10 times a to the 6th power. And even a to the 6th power is also its own multiplication. So there's sort of a long way you can write this out. And you could do this on the test. I mean, now I say on the test, so you're going to be clicking answers on a computer, but on your notebook that they give you or dry erase board, whatever you get, I would recommend with a problem like this, go ahead and write this out. I think for this type of problem, this is going to be a good strategy to use. There are some rules we can go with, but you might forget the rule, but this isn't super hard to remember if you know what this means, as long as you know what each part means. Because once you know what something means, you can apply that knowledge to lots of questions and not just this one. Okay, so does this make sense so far? On top of this line, we had 10 a to the 6th power, and that means 10 times a times a times a times a times a times a. Everybody good with that so far? quiet up there. Thank you, Brady. All right, now, can someone help me, now that you've seen how the top works, who could describe what you think the bottom should become? I'm gonna rewrite it the same way that I wrote the top. Who'll be brave? The
You want
top,
us to write down that
Okay,
the
what-
spectrum 2A,
yeah, what would I write on the bottom here?
it's 2, and then times A times A,
That'd be a negative.
times 8,
Negative
3
2
times, yeah, negative, yeah, sorry.
times,
3 times A
well, it's A times A.
and times
Is that
A.
what you meant? Yeah,
Mhm.
great.
8 times 8 times 8.
There you go. Now, the cool thing, once everything is all has what we call factors, where everything's multiplication, we can start canceling some things out. Now, they're not just like disappearing willy-nilly. What it is if I say this A divided by that A, now I don't know what A is or care, but the way math has always worked is if I divide, and I forgot to mention that, this line, that's division. So that could be important to know. So although 10 next to a number is multiplication, this line that separates the top from the bottom, it's whatever number the top ends up becoming, I'm going to divide that by whatever the bottom number would become. But as I look at each piece of it, like anything divided by itself, like if I ever had like, let's say 8 divided by 8 or 4 divided by 4, what does that answer always become?
0.
Ooh, try again, it's division.
One.
Yeah.
1. Yeah, 1. Yeah, if it was subtraction, it would be 0. Like if I said 8 minus 8, but that's not subtraction, that's division. So divide, think of it like this way. If I had $8 and I wanted to distribute it evenly 8 ways, well, each person would get $1, right? They would get $1 each. That's what that represents. You're splitting it up evenly 8 ways, or splitting $4 4 ways, where each person would get $1. So anytime we divide by the same number, it should be 1. So this A divided by A should be 1. That A divided by A is 1. And that A divided by A is 1.
Question. Always when we have the same common like A and A on the bottom, it's going to kind of eliminate in turns to 1, isn't it? At the same value, even though if you have the expression of V, it will be B on top and B on bottom, it will be the value of 1.
Correct, yes.
Okay.
As long as they have the same base, yes, if they're the
Right.
same letter. Yeah, yeah. That's a good point.
Thanks.
So if it was like A up here and B down there, well, those don't get to cancel. They have to be the same variable. So it could have been both B's, both R's, both S's. Yeah, great question. Now we get over here. Now remember, this is division. So what is 10 divided by 2? Or sorry, 10 divided by -2?
-5.
-5, great. And let me show you real quick how we can do that on the calculator. This is where I really enjoy doing this part, because this calculator has a lot of other buttons that normal calculators don't have. And this is the same version of the calculator you're going to get. You have to be careful with where these negative buttons are, because there's this minus sign over here, but that's not a negative. That's a minus, like we're going to subtract something. So if I want to do a negative, I have to hit this one here that's to the left of the enter button. It's negative there. Now the actual problem said 10 divided by -2. So you could hit 10. Now, obviously, the page we were looking at had a line, but we can use this button to represent division also. And then you can hit -2. That's how we can get -5. It's kind of interesting if you at least know some things, and then you don't want to trust your own brain for what the answers are. If you know some of the features of this calculator, that can really, really help. All right, so this is good. This is very good, because now that we know what this means, we've got 10 divided by 2. Shouldn't this really help us narrow down our options?
Yes.
Yeah, so it should be down to A or B, right? Now, also, now that we've canceled out some of those A's, should we now be down to the final answer? Who thinks they know which one will it be, A or B? Is it A? Is it B? We know the -5 has to be correct because that's what 10 divided by -2 is. All right, let's look very carefully. Look over here. How many A's did we have left over?
Okay, 3 is a
Three.
B.
It's B. There we go. What do you think of that? That seem doable?
Yes.
So just to recap then, it's about interpretation. This is 10 times 6 different A's, and we're dividing by -2 times 3 different A's. So then 3 sets of A's got to cancel. We had 3 A's remaining. That's where we get A to the third. We divide the numbers that were in front, and that was -5, and that's where this piece comes from. All right. Once you know that, it's like, oh, wow, that's not bad at all. I can pass this thing. Okay. Let me erase a couple things here. All right, 15. I would say this is not, this is not algebra, not geometry. They have like, I don't know, like I said, 10 to 15% of just, they call them like number operations, any sort of just regular old math that they're like, in this case, maybe percentage, maybe some like real life money math types of things. Okay. So we might be able to relate to this some because we've all been shopping before and we've seen sale prices. So how do they figure out, if something's on sale, based on what it used to be and what it is now, like what are the calculations happening to get to the actual sale price? So the sale price of a hat that Tyler wants to buy is 20% off the regular price. One way to determine the sale price is for Tyler to do what? So isn't this interesting? Because they didn't tell us the original price of the hat. They just want to say they actually are trying to figure out what you would do. Since you can't show your work on the test, they threw a question on the test that made you tell us what you would do if you could work it out. What are you going to do this? Are you going to have to multiply the regular price by 0.20, multiply the regular price by 1 minus 0.20, divide the regular price by that, divide the regular price by 1 minus 0.20, or divide the regular price by 1 plus 0.20? So the way I know, just to sort of give you some tips on this as far as like, how am I supposed to decide? Because we've got 5 choices, but really when you break it down, it's either multiply or divide. So we got to choose which one of those that we're actually doing. And then we need to figure out whether we're going to use this number, this calculation, or one time they used a plus. So
Is it division?
Say again?
Division.
Division. All right. By what?
Yes, for division.
By 0.2, by 1 minus 0.2, or by 1 plus 0.2?
It will be C that will give you the percentage.
0.2, I guess.
Let's divide by 0.2. Okay. All right. So that's what we're taking the regular price and dividing by 0.2. Okay.
Right.
So let's do the strategy I did with the rectangle, where I just like made up a number for the sides. All right. Since they didn't give us any numbers anyway, this is the type of problem you'd want to do that. So somebody give me a price for a hat.
Maybe like $25.
How much?
$25.
$25? Okay, great. So let's throw that in the calculator. Share that. So we'll take a $25
Wait, Bambi.
hat. Now let's divide that by 0.20.
Mhm.
We get 125. So the regular price was 25. We have a 20% off sale. Now we're going to pay 125.
Mhm.
Does that sound about right?
No.
No, I don't want to pay more. I want to sale. Right? I'll pay less. So what does that tell you? Just by doing that strategy, if you just try it,
Oh, it's
No,
not
that
correct.
one.
It's not correct.
well, it's not correct. You're right, but also maybe dividing is not the way to go. All right.
Hmm.
Looks like dividing by a decimal actually does the opposite effect here. It actually makes the price go, it would be kind of backwards, really. So so that kind of tells me that the dividing idea is not what we're looking for. So we're actually multiplying.
So it's A then, because we want to find the price of just 20%. That will be
We want
A.
to know what the actual sale price is. All right. So, all right. So let's try the multiplying this time. Yep, I see you, Christina. Okay, so now let's take the $25 hat and we're going to multiply by 0.20. And we get $5. All right, so it's definitely cheaper. Does that sound like 20% off though to you? That sounds like better than 20% off to me. That's a major deal, right? I mean, I would love to get a $25 hat for $5. I can,
$5, yeah.
I can afford that, but does that sound like a 20% off sale?
That looks like it.
So now we kind of have the opposite problem, right? Like the first time we did divide by 0.20, it was way too much. It wasn't even a sale at all. Like we're not going to pay more when it's supposed to be a sale. And then when we multiplied by that same number, it actually seems like it's way too low. Is it possible that maybe it's B?
No choice. It's got to be that one then.
I mean, that could be the only one left, but maybe let's sort of see if we can figure out why that is. So 1 minus 0.20. So let's see how we do that on the calculator. So we're going to take the 25 and we're going to multiply. Did you know this calculator has parentheses? It's kind of nice. So we can hit the parentheses. 1 minus 0.20, close that parentheses, and 20.
That's right.
That sounds more reasonable, right? Like if it's just 20% off, it's going to go down a little, Okay, now the question might be, why is that?
I got a question. If you are not using this calculator, how can we do this?
You will be using the calculator because it will be part of your test. It'll be
Okay.
at the top of your screen and you can pull down the calculator.
Okay, thanks.
And so we're going to be mailing you a calculator just like this so you can be practicing with it. So yeah, I was able to say confidently that there's no chance that you won't be, I mean, there'd be no reason not to because you have access to it.
And actually, David, you do
Yeah.
have that exact calculator on the desk too when you go.
Oh, like did they give you a handheld one?
Yes.
Okay, perfect. Yeah. Yeah, so it's built into the computer, and apparently from Christina, who has taken this before, can tell you that they'll give you one to use in your hand too. Now, so anyway, back to this problem here. So I guess I want to get down to the why does this work? So this when we say 1 minus 0.20, the way I guess I would look at this is when it says 20% off, right? Like if I have if I have hair that's 10 inches long and I cut some off, if I cut 20% of my hair off, I'm going to cut off 2 inches of my hair, right? So now it'll be 8 inches, right? Does that kind of make sense? The word off would tell you that we should be subtracting away 20% from, well, this one really is kind of like saying it's 100% like the original price minus we're taking 20% off of that. So you are paying 80%, but it's taking 20% off. Does that make sense what I'm getting at there? That's why the answer is B. But you can kind of see, like, obviously I spent a while on it, but I want you to be familiar with it. So if you see something like it, maybe you'll get through it faster next time. And you can always, if it's very vague in their question, they're speaking generally, make up a number, try some out, see what makes sense. And that helps you also narrow down some options. Okay. Try maybe, I was going to say maybe a couple of easier ones that won't take as long, but I don't know if I have any that I would necessarily call easy. Actually, you know what, 22 doesn't look easy, but because we did something almost like this, I think I want to try this one. So we're back to algebra. Like I said, that you can expect that half of the questions will be either something that looks like this with numbers and letters, or you might have some sort of graph with lines on it, you know, lines on a graph, you have to interpret that. So which expression is equivalent to this? Now, remember, this has a meaning. In between the 6 and the variable is like invisible multiplication. This means 6 times this x times another x plus 4 times that same x. And that whole answer all divided by 2 times x. Now, if you remember ever like learning about fractions, do you remember how, this may take you back to your elementary school days, but you would have learned how to like add fractions like, oh, I don't know, 1/8 plus 5/8. And they said that as long as you have a common denominator, you could just add the tops together. So do y'all sort of remember that? That would just become 6/8. I guess it's okay if you haven't. I don't want to embarrass if you're like, no, I've never seen that in my life. But that's how fractions work when we learned it back in elementary school. We just keep the bottoms and just add the tops. So if we went in reverse, if I started with this, I could just take 1/8 plus 5/8. So that's basically what we're doing here. This is just a general way to describe what we learned in elementary school. So we're going to take that as its own fraction. And also that as its own fraction. Okay, so that would be the first thing you would want to do. We're not done, but that's the first step we would do. Let me scroll back for just a second to remind you of the problem we did. Was that maybe the first problem? No, the second or third problem did. Yeah, this one right here. Remember how we kind of broke that down like this? What we're basically doing on number 22 is like having 2 of these problems in one. Okay, so we're gonna sort of break this down like we did on number 14. So 6x squared, we said that's the same as 6 times x to the second power means I'm multiplying x times another x, all divided by 2 times x. And then this is not really a whole lot extra, but it's 4 times x divided by 2 times x. Okay, so now let's sort of divide with this problem. So remember we said once we have all multiplication, we can cancel some things out, like this x will cancel with that x. That's like dividing that by 1. We can also, if we have 2 numbers, we can just divide that So what will we get? 6 divided by 2,
3.
3. And then we just had 1x remaining. So there's that. Now, if you really pay attention to your choices, I would propose to you that we are done with this problem and I know what the answer is. Anybody see it?
Yeah, we see it is a C.
It has to be C. It doesn't matter how much time we take to do the other one. This is a time test for crying out loud, right? Like, get it and move on, right? We don't want to run out of time. So if you get that first part right, then we're good to pick C. But you'd also have to be careful that E has 3x squared, but you see one of those x's are gone, so you don't have x squared anymore. You just have x left over. But just to sort of practice though, I'm not suggesting, I think strategy-wise on the test, you're going to do what I just said, but just to practice how to do this, it's the same idea here. These x's are going to cancel, and all we have is 4 divided by 2, which is 2. And then just don't forget to bring down that plus. So that's how we can say that this expression here is equivalent to that expression. Exciting stuff. But my hope is that things that might have looked like some wild and crazy language has now been brought to life, and feeling, I want you to walk in more confidently than you had before you came to class. Okay. Well, I would love to do more math. That's my favorite subject, my specialty. But we do have other subjects to work on. So I am going to move ahead. But remember again, for those that came later, we are going to do, today's Thursday. So Monday, we still have regular class. So same procedure for that night. And then Tuesday is our first of many to come, maybe monthly math boot camp. So we're just doing math on Tuesday night, but that won't start until 6:30 Tuesday. So we'll get to do more of this kind of stuff for, a little bit longer than just 45, 50 minutes. All right. Any questions about any of what we did tonight? I need to go back to any of the other ones. And always feel free to stop me with questions. Since I can't see you, I can't like read your face to see if you're confused or anything. No questions? All right.
No, thanks.
All right.
No questions. Thank you.
You're welcome. All right, so let me go ahead and move it along. And Annie, just so you're aware, at 7 o'clock, we always take a 15-minute break. So I'll just kind of be getting started with something, and then we'll break for 15 minutes and come back. And
Okay. Yeah, so in 15 minutes we get back, right?
correct, yeah. But
Yeah,
we're
thank you.
gonna at 8 o'clock, or sorry, at 7 o'clock is when we'll start the break.
Okay.
Let me see if I can find. Here we go.
Oh my goodness.
Sorry, I'm having trouble finding my screen share thing. There we go. Okay, so next topic for tonight, this is going to be under writing. So on HiSET, they have 2 different language arts tests, because there's a total of 5 tests that we take. 2 of them are language arts tests. One of them just focuses on reading, the other focuses on writing. And even though they call this a writing test, the only writing you do is at the end of the test where you write an essay. But the great majority of the test is actually correcting sentences, correcting punctuation, capitalizing, correct forms of words, and so forth. So this is a official practice test that was used a couple of years ago that is now for free on the website. The actual test in person, when you take the real one, is actually 2 hours long. So it is actually, I may be wrong on that. Actually, I think it might be almost like 2.5 hours long. So this is about half the length, just the practice test alone. So you'll get probably, if I had to guess, like 40, 50 questions on the real thing and still just one essay question. And so what'll happen is they'll give you this long passage. And then I've been just telling everyone, even though the test is going to present it this way, just scroll on past that because they're going to give you the same passage again with the actual questions off to the right. And so they'll underline certain portions of the passage and you have to answer a question specifically about that, or maybe about, they might just underline one word and you have to fix the word or fix the punctuation or something. So this is what we did the other day. So that's why I've still got markings in there. So I'm going to go to the next one. It's called My Journey in Bordeaux. I think that's how I would say that. I can pronounce French a little bit. I can't, but I think that's how you pronounce that. Okay, so here we go with this. And because this isn't like a reading test per se, it's really, we really want to focus on what's being underlined. If you're spending too much time reading, then you might be wasting unnecessary time. All right, I am going to go ahead and read just for now, though, just so we can kind of get some connections here. But this is just seems to be like a story that someone's telling about their adventure. I'm Alia from Indonesia. Few experiences in my life have such a profound mark on my personality as studying abroad in Bordeaux, France. Stepping foot on French soil for the first time, little did I know that I was beginning a journey that would not only reshape my career,